next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
What?
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too dark. Wake up, my love. Please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love. Please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day here in 100 days of rootkit. And we got that green screen glitching out a little bit. We'll fix that in a second. I hope y'all are doing great. Alright, we've been doing our journey of SQL here in recent days, and today we're going to show how it kind of combines a little bit with Python and how you can get some big power out of it. Big power out of it. Now again, sorry you guys, there was no stream yesterday. I was pretty ill yesterday, so we're past that now. All right, so we're back here and we can continue chugging along. Did the music play? All right, good. All right, sweet. Before we continue forward, let's finish up our intro and then I'll fix this green screen issue going on right now. If you guys don't know, we are Rootkit, a non-profit organization here in the US of A. Hold on one second. Non-profit organization here in the US of A. Don't go to college. Don't go to any other boot camp. Just come to us. Watch these 100 days. Look through our roadmap for a comp sci cert. Learn everything you need to and get our comp sci cert. Get yourself a job. All right? No reason to waste all your cash. If you want to waste your cash, look, you can donate to us, right? Avoid those taxes, all right? Government's just stealing your dollar bills anyways. They ain't doing anything good with it. So just help out a nonprofit here. Additionally, if you go over to our blog, we have our week, never mind, we don't, because I didn't send it up. We don't have our week 11 giveaway. I swear I set it up. Did I not turn it on? I don't know. The week 11 giveaway will show up here. I'll post it in the Discord when I have it up on live. You can submit there. It's completely free. You can submit and enter to win and get yourself some free merch. Additionally, if you click on the link in the description of the video or somewhere on Twitch, you can donate. All donations are matched 1-for-1 for the first 10,000 donations. Depending on how much you donate, you can unlock certain rewards like our epic stickers, our epic 100 day of Rootkit stickers, t-shirts, and our epic sweater. Look, I got it on right now. Got the exclusive 100 day of Rootkit little emblem there and the Rootkit logo. Epic. Additionally, we have goals along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one we don't really want to hit, which is shaving my beard. No one wants to see that anyways. All right, so we don't need to get there. All right. Alrighty, sweet. I thought it just like auto fixed itself. Let me go ahead and fix this. If you guys have any questions, comments, concerns, go ahead and place them into the chat. I'm looking at all of them right now, so you can just go ahead and ask away while I finish up tweaking this webcam real quick. Oh, now you guys get to see the whole green screen. There we go. There we go. That's looking a little better. All right, sweet. Let us continue on with our journey. So we've been talking about SQL and databases, and SQL is one of the most popular types or styles of databases, but there's lots of different databases out there. We've been going through and showing Postgres, I believe. Yep, our Postgres database. And we'll show some Maria here later on. And it's pretty much the same as MySQL. And let's get to connecting this up to a Python program and seeing it in action. Now, my screen is back to normal size, so it's not zoomed in, so you can't really see maybe the database layout very well, but this is exactly the same layout we had from before. All right, same layout that we had before. So we got a users table and a tweets table going on. Nothing crazy, nothing new. All right, nothing crazy or nothing new. The next question is, how do we connect this to our Python programs or any program in general? And how do we use it to save information, recall information, really empower our applications here, really empower our applications? Well, whenever you ask yourself these questions, the first thing you should do is go Google. Go Google, go search, go figure this stuff out. You have to be a researcher, all right, in order to look up and find and continue your programming career. So where I would personally start when Googling this stuff would be Googling Python and then the database we're using. So we're using Postgres. Postgres. All right. Usually every database will have a companion Python library. I guess I shouldn't say Python Postgres. I should say like pip, because we want to pip install an additional package for Postgres stuff. And we can see PyPy, which is for pipping, right, has a Postgres library. If we look at it, very little information, not very many stars, so this might not be like a quote-unquote more official one. All right, and if we look at it, it's been 2 years since it was last updated, so this might not be the one we want to utilize. They're referencing this is coming from that thing. So I'm guessing it's this one right here. So just because, you know, this is the first link that you click on, look around again, because remember, just because it's open source does not mean it's good software. A lot of times it can be malware, right? It can be malware. So this is being used by some people, it looks like, but it's not that popular, and there's no information here. So I would probably just straight up avoid this, and it's referencing this copy2 thing. So let's take a look at this one. All right, this one looks a little bit more formal, has a lot more people starring it and potentially utilizing it. So let's go with this one instead. All right, mostly also because this one has been updated more recently, so it's live, it's being worked on. So let's go with this one right here. All right, so before we do that though, let's look at this a little bit more, make sure it works for Postgres, and then let's see how we would go about using it before we pip install it, because maybe we want to go with this one, maybe we don't want to. All right, you got to go through a process, research, look at stuff a little bit. Unless you know the package beforehand, all right, look at it a little bit more. So this is claiming to be the most popular Postgres SQL database adapter. What does that mean? All right, a database adapter basically means a way for you to interface with the database. All right, it's just a library for you to interface with the database. All right, for the Python language, its main features are the complete implementation of the Python DB API 2.0 spec. Interesting. All right, it's all done in C, so it's all written in C and then letting us use it in Python. Interesting. Well, this tells us how to set it up. There's a documentation link right here, so let's go ahead and open that up and check this out. All right, very pretty looking documentation here. Not really, but they have a quick install section. All right, it looks like it's just this easy to get set up and running. We do the scicopg, I don't know how to pronounce this library, I'm sorry guys, .connect, and we just say the database's name, the user, and I'm guessing there's a way to maybe do your password also, because we have a password. All right, if you don't know, well, we'll go through this like kind of like a beginner, and then we'll go through these Googling steps that you would want to take. All right, so far this looks like a database that we can definitely utilize and start getting to work with, or not database, but an adapter we can use. So let's go ahead and pip install this. So let's copy this right here, and let's go to our VS Code. Let's go ahead and make a new folder here for databases, database testing. All right, you can call this folder whatever you want. All right, we're just gonna put a little file in here for Postgres testing.py. Let me go ahead and zoom in a little bit for you guys. All right, again, the folder can be called whatever you guys want, and the file can be called whatever you guys want. I'm just gonna call this folder database testing, and in here a file called Postgres testing, because we're just gonna be testing things out. We're not gonna be potentially making a game just yet. We first need to figure out how to actually use this library, you know, mess around with it a little bit. So it's best to make a completely different file so you can mess around with it before we start adding it to a game like our word guessing game or our dungeon crawler game or whatever thing you want to implement it inside of. So let's go ahead and open up our terminal here. Oh, that's really big. And let's run our pip install. PsychoPG. Is that what it's called? I see. My God. Some of these names, man. All right. So looks like we got it installed. All right. Looks like we got it installed. And looks like my camera is all messing up. So I'll let you guys catch up here a little bit while I fix my camera. Again, all we did was pip install this library so far. There we go. I think that should be good now. All right. So all we've done is pip install this library and then made a new file for us to do some testing. All right. Because guess what? There's lots of Python libraries out there. All right. It's hard to know them all, but also you may use one and forget how to use it. So you may need to refresh yourself a little bit. So make a new file, just refresh yourself a little bit. It's not, the end of the world if you have to do that. That's completely normal. So if we go over here, again, most of these doc places will have some type of quick start or installation page. They'll usually show you how to start things up also. So it's usually best to try to navigate to those to see if you can, get some startup script, which we got one right here. So let's go ahead and copy all of this startup. What is going on? Are you kidding me? Okay. I guess I'm gonna have to type in the IM myself. So let's go ahead and copy this up, minimize, pull this up, and I gotta put the IM in right here. All right, and we have their code. Luckily for us, they added comments for us. So we can kind of get a head start on what we're trying to view here. So this line is supposed to be for connecting to the database. All right. We don't really know exactly how this works right now, but we can kind of guess. All right. We can kind of guess that DB name is for the database name, user is for the username, and we have a password. So we're pretty sure this is going to fail, but we don't know. So it's always free to try things out. So let's just try it and see if it fails or not. Additionally, we have this thing called a cursor. So open a cursor performs a database operation. All right, interesting. Execute a query. Well, we know every time we want to do something with the database, that's going to be a query, hence the Q in SQL. All right, it's going to be the query. And we have to use, it looks like, we're inferring from looking at these docs right now that the cursor is the way we perform queries, not the connection, the cursor. All right. Additionally, when you perform a query, it looks like it doesn't just return to you the results. It looks like we have to take an additional step to retrieve all of them with this fetch all command. This might seem a little cumbersome and like a lot of extra work just to do something relatively simple. Yes, it is pretty cumbersome at first. All right, at first. It seems like a lot of steps at first. But the more and more you get used to this technology, the more you will realize this is the best way to go about doing all this. And this is actually a smart way for them to set it all up. One last thing though, we know that is a couple things, I guess, two things that we know that's wrong with this, all right? We know our database is not named test, and we know we don't have a table called my data, all right? So if we pull up our DB over here, we can see our database is called Postgres. That's what the default name of the database is. So we should copy user and paste it right here to DB name since it's called Postgres, not what was the test, right? So let's replace that. Additionally, you got to start getting more and more familiar with your SQL statements. We talked about selects last time, so on Saturday, and we talked about kind of the format. Select, and then you get to choose what data you want. So these are the columns you want. Asterisk means everything, and then from is what database, or sorry, what table we want to choose stuff from, right? What table we want to choose stuff from. We have no table called my data. If we look at our database though, we do have a table called tweets and a table called user. Also, if you do forget how the select statement is formatted, remember you can right click and generate SQL and click on the select statement here, and you can see a select statement get auto generated. So let's copy this. Whoops, I don't want to close. And we could paste it right here. So here's the SQL statement that got auto generated to us. We know that we can type every column out, or we could just do asterisks. So let's just do asterisks. All right, and it looks like public.user is guaranteed to work because that's what the database is generating, and we can run it and see it work. So let's replace my data with public.user. All right, let's go ahead and do that. So looks like we've set up our script. We don't know if this will work correctly because, again, we know we have a password on our database, so we think this will fail, but guess what? Whoopsies are okay. So we can just go ahead and run this anyways. If it fails, we already knew it was going to fail, but at least we know it's actually trying to connect and do something. So let's go ahead and run this. So I'm going to do Python, Postgres, Photoshop. Oops. I got a CD into this directory. Database testing. Again, you can just press F5 or the play button. Come on. Why are you? There we go. All right. Sweet. So let's look at this. We got an error. All right. We got an error. And looks like this is our entire error. So it's best with most Python errors, again, to always start at the bottom. All right. Always start at the bottom when you read them. All right. So it looks like we have an operational error. What does that mean? I'm guessing it tried operating and had an error. Let's continue reading. It says connection to the server at localhost port 423 failed. So we couldn't connect to the server. Why? Is the server down right now? Is it broken? I don't know. It could be a million things on why we can't connect to the server. Let's continue reading. FE send auth. Maybe you don't know what FE stands for, but send auth sounds like authorization stuff. Interesting. And then this says, it's kind of weird because the N is right here and the O is right here, but it says no password supplied. All right. So if you need to read your errors completely, because if you read this and stopped, you would think that maybe your server isn't working or online because it cannot connect to it. Wrong. You have to read the whole thing. It is connecting to it. It just, you're not supplying the password and it requires the password. All right. So the password is missing. Now, there's a couple ways you can go about solving this. How do we give it its password? One way is you can infer that most likely we have to do password equals and then whatever our password is. In my case, I made the password. That is one way of doing it, and then you can try rerunning it and see if it works. And it looked like it worked for me because we didn't get an error that time. If that didn't work for you, or you didn't go about inferring that, you can also hover over connect and look through the little info that comes up here, right? Create a new database connection, all right? And it looks like they have some examples here, all right? So connection parameters can be specified as a string, so everything can be done as one long string, or it can be used with keyword arguments. So what we've traditionally seen with, variable name equals and then a thing. And then it says right here, here's all the options we get. Database name, database, user, password, host, and port. So this is another way we could go about figuring out this information. Finally, the other way, I guess, besides just straight up Googling this question, would be going back to the docs and going to that connection class here, the connection class, because that's what we're using right here. We're using connect. So we can click on the connection class. Never mind, it's not this connection. Class is the connection function. Let's see, connection function, connection. Here we go. Connection constraints, connection pooling, connection class, connection and cursor factories. Maybe it's this one. Nope, doesn't look like it. So it might be best if it wasn't showing it up initially and you're not really seeing what's obvious here in the docs, which is a very common thing, right? Very, very common thing. Developers aren't great with their documentation or the docs they make. Then Googling may be your final answer. Besides, like, the last option is going through the actual, like, code yourself and having to look for stuff. This is just for the cursor. Yeah, the last option, wait. Yeah, okay. This is connect. Yeah. So, okay, these docs, sometimes Googling is probably going to be your quickest option. All right, straight up. The last option is to really go digging around in the docs or looking at the code, because it's very common for situations like this to be here where we can go to the connection class, but the connection class initially has nothing to do with connecting. It's about the cursor and this commit thing and rollback. All right, but they'll leave sometimes breadcrumbs for you, like right here, a link to the connect function, which is what we want. We were looking for this. So if you click on this, then we can get to the docs and we can get our answer with some examples here and information. You'll also notice that these docs and this information will closely match what happens when you just hover and look right here. Why is that? Because a lot of devs will add their docs in their code attached to these functions, like if we click using the doc strings, and then they'll use special programs to extract this information out and auto-generate the docs website for them. That's why the doc websites a lot of times suck, because they're not like really custom-made doc websites. They're auto-generated and being pulled from code, from comments in the code like this, which you get really mixed results. All right, so that's why I highly encourage is making sure you hover over and check things out. Right, look at the information here. So now we are connecting the database and it looks like it's working. It looks like it's working. The only thing is we're not printing out anything. So let's go ahead and print out our records. So let's do a print our records and let's rerun this and look at that. We got our information from the database. We got Elijah Harmon, we got Joe Blow, we got Tim Toe, we got Joe Walb, and we got Kate Finn. All right. So we have fully connected to the database. Any questions so far before we continue chugging along here? Again, if you're a Patreon or Discord premium member, you can hop into the events chat in the Discord. I am in there, and you can just ask questions at any time you would like. You don't have to ask into the live chat here. Milo says, I'm connected. Epic, epic, epic. Any other questions? All right, so all we've done so far, again, is just use their setup code, connect to the database. We got some functions here that run, and we're getting all the records printed out from the users table. So the cursor is what you use for navigating through the database. You don't use the connection, you use the cursor. All right, the cursor allows you to navigate through the database. So these pretty much can be right next to each other because they're required. You make a connection and then you make a cursor. All right. Next, to execute you can have dot execute, all right? And you can use this to execute any type of query. Any type of query you want, whether that's creating things, updating things, making new tables, deleting tables, selecting things, searching, any valid SQL query you can put right here and it will work. All right, it will work auto magically. All right, so that is super, super epic. Let's see here. And then to actually run it, right? Because it's kind of a two-step process. Even though it says execute, it's like kind of executing, but not really. You have to additionally do a fetch process. Now, we're doing a fetch all here, but if we do cur dot, you'll see there's lots of pre-built items here. And particularly when we go to fetch, you'll see there's fetch one, fetch many, fetch all, fetch many, and fetch one. All right, fetch all makes sense. It would be everything, all the results. Fetch one means only the first results, and fetch many, I'm going to assume is going to be for, yep, right here. You put in the size and how many you want to get. All right. So for example, if we run this and you look at fetch all, which is what we ran, you'll see all the results come back. But if we do fetch one, fetch one, you'll see that we only get one result back. All right. Now, don't be confused because our statement here is getting all of the records. All right. It is getting all of the records. This is just filtering things out for you. So you're only getting one of the records back and then printing it out. All right. If you only ever want run record, it would be best if you were only getting one record only through your SQL statement. All right, through your SQL statement. And this is something, again, you guys got to get semi-familiar with your SQL statements, because if we pull up the cert guide, let's go ahead and go certifications, comp sci cert, view requirements. Over in here, we got databases. All right, SQL databases. You only need to know about SQL databases for the exam. We need to know our select statements, what from is, insert into, update, delete, group by, create database, drop database, create table, drop table, where, top, limit, fetch first, row num, join, enters, having our operators, some keyword stuff, which is mimicking some of the stuff from before, and then some basic functions that are in the language that you can utilize. All right. Now I'll bring this up because you guys should be experimenting with these. But additionally, by looking at these, you're going to see something here specifically called limit. All right. Limit is a clause that allows us to potentially limit the amount of data that comes back to us. All right. Because again, you don't want to send a lot of data over the network that you don't have to, because that's a very expensive and slow operation. All right. So a statement like this is not ideal if we're only going to do fetch one, because again, it's very expensive to do all the data and then just only end up getting one. It's best to limit it. All right. So at the very end of pretty much all your SQL statements, you could use the limit clause, where you say limit, and then you say, how much do you want to limit it to? I want to limit to one result. So the database will only give us one result back, and we're being as efficient as possible. So now if we do, we rerun this, you'll see we still get the same results. And that's using fetch one. We could also do, I think fetch all will still work also. Yep, we did fetch all. That will still work also. But you'll notice that we'll always just get the one result, because we're limiting it to one result only, right? One result only. So just a little new term for you guys there for SQL. But let us continue on, shall we? let me think on what for us to go through next here. Let me pull this up and let's take a look at the docs here. So I'm going to show off something that can be potentially dangerous. Very, very, very dangerous. You will be destroyed. Your program will be ruined. You could potentially just tank an entire company. Not good things. Not good things. And I'm trying to find where they have their protection for it. We might have to do some Googling for their stuff. There's an issue here. All right. In particular, I guess before we get to the issue, we can do any type of queries from this. Any type of queries we want. So if we wanted to add a new user, we can, generate that update statement. We can grab that update statement. That's not an update statement. Sorry, insert statement. So let's go ahead and generate our insert statement. Grab that code. Go here to our SQL statement, and then we can do our insert. But let's do triple quotes so we can do on multiple lines. Will triple quotes work? I don't know. We'll figure it out. So we want to insert a new user. All right. We need their first name, last name, email, create time, and an IP address. Right? Create time and an IP address. IP we don't need to fill in. So we can go ahead and do a first name here. All right. And let's do Bob. And let's do Joe. And then let's go and put an email here, and let's say there we go, .com, and let's go ahead and do a time 10 10 10, and then the IP we can just leave blank. All right, the IP we can just leave blank. Now if we go ahead and run this, there we go. Looks like it ran. It says there's nothing to fetch because we're not doing a statement that requires us to what do you call it? That will be returning any type of data. All right, this won't be returning any type of data, so we could comment this out and rerun it. And it looks like, oh whoops, we got to comment out the print statement too. Now this will look like it works. All right, so it ran. No errors, so everything looks successful. Let's look at our database here, and let's click the refresh button here. And you're going to notice that there is no new user here, which may be very confusing. To you, all right? Because we connected the database, we're executing a query here, but where we're adding a new user, there were no errors that were returned to us. But it's not showing up. There's a simple solution for this, all right? Because what happens is every time you execute a query, as you've already seen, it's kind of a two-step process. When you select stuff, there's 2 steps you have to do. When you insert new data, there's going to be 2 steps you do. Well, it's not just for inserting, it's for pretty much any task you want. There will be 2 steps. All right, there will be 2 steps. All right, what happens is when you perform these queries, the first step is kind of think of it like a staging round. You are staging or getting ready to do a thing. The database has seen what you want to do. It's ready for it. It has it kind of pre-made in a pre-made like waiting area, and it's ready. All right, it's ready for you. What do I mean by this? Well, let's even visually look at it. If we run another statement here, because we already have our fetch, let's run our select statement. So select everything from public.users, right? Select everything from public.users, and let's print, except we don't want to limit and we want to fetch all because we want to see all the users. So if we run this right now, so what's happening right now? We're connecting to the database, we're generating a cursor. The cursor is the way we talk and integrate with the database. When we've connected to the database, we've executed a statement. This statement we just executed was for adding a new user. All right, for adding a new user. But we can look at the database and we can see in here, no new user has been actually added to the database. So why isn't this working? It's even more weird because if we do a select all here where we get all of the users in the database and look at our results, look at this last line right here. Bob Joe, look at this. Bob Joe. What's going on here? And the database doesn't even have the record in here in the user section. What is going on? You're not losing your mind. All right. Again, it goes to a staging section. All right. Where it's kind of like a waiting room where you queue up everything you want to do. You're able to mess with that. It's in the database, but not fully added to it. All right. Remember that word commit from Git, right? From Git. What does commit do? A Git commit do? That's an official save. All right. That is a official save. You do the same thing here with your databases. All right. You got to do an official save when you are ready. All right. This is an important feature, this staging feature for databases, because it helps protect against you potentially adding in data you didn't want to add in the first place. For example, let's say you were wanting to make an application where a user account is going to be made, but only if they what's a better example than that? I'm blanking on a good example right now, but it's a way for you to go about adding someone and continuing your logic without fully saving them, so you could do some last minute validation if you want, or maybe you want to make sure like certain things also are guaranteed to happen first before their account is made. God, I'm sorry, guys. I'm trying to think of an example right now, because I mean, this is done pretty often. We do it all the time in Project 26. But I can't think of a good example right now. But everything has gone to a staging ground. All right. And you must commit. Just like in Git, where it's an official save. So when you want to officially save, commit your choices, you do cur.commit. Commit. Is it not called commit in this one? Or is it connection.commit? All right, connection.commit. I believe. We'll figure out here in a second. All right. So you usually have to run some type of commit, which is fully saving what you have done. All right. Again, this goes for any type of altering action you take. New tables, new users, new records, updating records, adding columns, removing columns. You must always perform that commit afterwards. So if we rerun this now, you'll see we get the same result as we always do. And if we look at the database now and refresh, you'll see that, all right, it didn't go through. Let's go look at the docs and see how we can perform our commit. All right, let's see how we can perform our commit here. So cursor class, and I swear the cursor class had a commit in it in here. Withhold, execute many, call proc, set, fetch many, fetch one, scroll, ray size, row count, last query, cast, execute. Let me rerun this. Did I save? Make sure I save here. And let's rerun. Let me refresh just as a sanity check, because sanity checks are good. I hate that all these libraries have everything slightly different. And let's go to what is this thing called? Psyops G2 cursor commit. Execute fetch one, make the changes. Oh, do we need to close the connection too? Make changes on the database that persist. We definitely did this. Cursor close and then connection close. This says it's supposed to persist the data, so I don't know why closing it doesn't send the commands. All right, let's try closing the cursor and see if that, and the database connection, see if that works. Not quite sure why it would be set up that way, but every single library does something oh so slightly different than everyone else's. So let's go ahead and put this at the end here. Let's just see, putting at the end, does that, I don't know why that would, nope. Are we on users? Oh. You guys are supposed to help me out with that, all right? All right, you guys are supposed to help me out with that. I'm over here sweating like, why is it not working? We're looking at the tweets. We're looking at tweets. We're not looking at users. Let me go to users. All right, there we go. We got a lot of Bobs in here now. All right, so it has been working the whole time. We didn't have to close no connection. All right, so commit, we'll commit all that data. It would be best if you look at the right table, all right? You'll leave me hanging there. All right, so you can see the data is actually showing up in here now. All right, so our users are actually showing up in the database, which is super, super cool and super, super powerful. All right. This also can potentially lead to massive exploitive issues, right? Exploitive issues. Using SQL by itself is completely fine, completely normal. All right. But anytime, again, your users are going to be the devil. All right. Think of them as the biggest demons in the world. Never trust them. They're out to destroy you. Right? You need them, right? You need them, but also they're out to destroy you, right? Because anytime you get users input, what does that mean? That's right. That's our reoccurring theme. That means you can be exploited. Things can go wrong. You must do sanitation. You must do input sanitation. It is a must, not a meh, maybe. No. You have to do it, or else you will be exploited. You will be exploited, all right? And if you go to a big company, your company will end up eventually on the news for losing millions and millions of users' accounts, all right? You must sanitize all input. You might be asking right now, what do you mean? We didn't get any input. Well, yes, we're not getting any input now, but how do you think you're going to get their name, their last name, their email address? They're going to give it to you. When they give it to you, if they're a normal user, it will work just fine like this. If they're going to be a bad user, and that could be bad because they want to hack you or bad because they're just dumb, they're going to ruin everything. All right, what do I mean by that? There are a whole line of exploits for SQL. Every single service you've ever used is going to be using a database. Most likely, it will have a SQL or NoSQL database running it. And there are lots of exploits for these databases, all right? The most common one for SQL is going to be your SQL injection, right? Your SQL, not insert, injection attack, right? SQL injection attack. Sounds very sophisticated, doesn't it? No, it's not. It's very, very simple. It's very, very easy. It's very easy to perform as an attacker. Why is it easy to perform as an attacker? Because if you do not sanitize your input, I can put potentially whatever SQL code I want in here. Because if I say something like user input equals this, and then I say that, where's my, right here, dot format user input, and I say Bob, that's fine, right? I say Bob, that's fine. Let me do this example on a smaller statement right here. Well, that doesn't make as much sense. I'm just gonna remove, look, this is not gonna be like functional. I'm just gonna remove this so it's not as there's not as much stuff going on, so we can focus on what I'm showing here, the exploit. If we do this where, you know, first name, and then the user is inputting their first name and they say their first name is Bob, and this will be added to the SQL statement, right? That is normal. That is okay. That's fine. But we're not performing any type of cleaning on this data. No sanitization. So we've opened ourselves up to a SQL injection attack. What does that mean? Well, what if instead I said Bob, but then I did attack right here, and then I said, this is how to make a comment in SQL, and then I say right here, drop table everything, or I don't know, just some type of thing. What did I just do here? I injected SQL code into this statement, right? Into this statement. I don't think this would validly run. We'll look at some examples here in a second. But you just put your own custom SQL data in here to do something malicious, like maybe delete rows of data, delete tables, or even return data. Return data they're not supposed to see, maybe passwords, maybe who knows what. All right, because we're not cleaning this, they can put whatever they want in this string because it's just a string of characters. So to see this fully, if we replaced it like this, this is what it would look like. They finished off this value section, all right? So this is a whole thing. And then they're running another command here, which we'll see here in a second. I can't remember what it is. I don't think it's an and statement. I think it's an or. And then this is how you make a comment. Oh, actually, no, you can do, I think, there we go. We can do a semicolon to say that's the end of the line. This is a new line with a semicolon. I'm pretty sure you can't do asterisks for your drop table. And then dash dash is your comment. If you don't believe me, if we go over here to our SQL scripts in the database, if we want to comment out a line, if we do dash dash, you'll see it goes green. We've made that line a comment. And you know what happens with comments? They're completely ignored. This is a SQL injection attack because we've injected brand new SQL into the SQL statement to do something bad, to do something malicious. All right. So we can go ahead and check out this site to go get a look. And let's see here. So this is again showing off a SQL injection attack, how it would look more in the wild. So categories. If you're doing a select statement, so aka we've seen select statements select everything from users. All right, we've seen that, or tweets. Theirs is products. So they're doing a select statement to get all of the products, right? All of the products where that equal a certain category. By default, the user gives the category. So they say the category gifts, and that will work like normal. That will work like normal. But there isn't proper sanitation going on here. So if they add something like dash dash, guess what? Now they've put a comment. Everything following it will be a comment, and they can get potentially more information than they're supposed to. And you can go about this. Basically, these are like the ways to do a quick nut tap, essentially, against the program to see if it's protected or not. And if it's not protected, this means that you can move forward with writing out an actual SQL injection attack, right? Because no one wants to waste their time writing an entire attack out for a service if it's not guaranteed to be even exploitable in the first place. So these are kind of ways you can go about testing and seeing if something is exploitable in the first place. All right, so you can see here, this is trying to get some, this is maybe what you would be doing. Please don't. If you are making an application with users that are logging in and dealing with passwords, my advice to you is use a third-party service for user authentication. Do not mess with passwords yourself, because most likely you're going to mess it up. Passwords should never, ever, ever be stored as plain text. They should be stored as hashes, particularly salted hashes. If you don't understand what those are, we've talked about hashes, not really salted hashes that much. Basically, don't mess with it. Just use a third-party service. All right, just trust me on it. It's best for everyone. Is this similar to pen testing? Yes, this is pen testing, but you should be doing pen testing as a dev. It's a part of your normal testing. All right, because if you're pushing out products that you're not testing and are exploitable, you are the problem. You should not be developing for any company if you're going to be doing that. All right, you are the problem. These are, again, massive attacks that can leak lots of data. So for this example, you can bypass the whole login process by just doing a SQL injection attack like this. All right. These are not hard things or complex things where you need to be a PhD in order to solve. These are very simple things you just need to do. Generally, it's all solved by one rule. What is that rule? Again, you know this. All right, we talked about it many times. Never trust the user. They're the devil. Sanitize everything you get from them. As long as you follow that, you're going to be good for pretty much most exploits. All right, pretty much most exploits. The exploits that aren't a part of that, you can't really protect against everything. All right, you can't really protect against everything. Like, for example, if you're running this on a Ubuntu server or a Windows computer, if Windows is exploitable, look, there's not much you can do. All right, there's not much. You didn't make the operating system. The most you can do is stay up to date on your patches. But when it comes to your program, you wrote it. You're responsible for it. Just sanitize the input. You're going to protect yourself from pretty much almost every attack that can go against you. All right. So let's show off this attack a little bit with our database. All right. So I'm going to get rid of this addition right here, and we're going to do our querying our users here. So let's say we want you to select a user based off their username. All right, so select all about a user from public user where their name, so their first name, let's just do their first name, is equal to whatever the user types in. So format, and then we'll do user input. All right, user input. Exit here. There we go. So if we want to look for all users with the name Bob, we could do that, and then we could run this. I'm going to cd into database. Oh, whoops. Python Postgres. There we go. Bob does not exist. First name Bob. Oh, we need to do quotes. We need to do quotes around this. So let's put quotes around it. There we go. So it ran, it said it couldn't find anyone with Bob, and that's because it's capital case sensitive, right? It's case sensitive. So we did Bob all lowercase. So we need to do Bob with uppercase and lowercase. We'll go over later how you can go about filtering that out. But if we do Bob now with uppercase B and then OB, you'll see we get 3 results. We get 3 results here. That's pretty cool. That's pretty cool. And we're just printing them out, and awesome. We did it. Now, we can potentially now go about doing a SQL injection attack here. A SQL injection attack because we're not doing protection here. We're not doing any proper protection. So if we had maybe another table that was for sensitive password information, let's say it's the tweets table. Our tweets table is, let's say in this example, passwords for users. All right, very sensitive information. Maybe it's not passwords. Maybe it's social security numbers or ID numbers or like license ID numbers or credit card information. I don't know, you name it. All right, something that people wouldn't really want there to be leaked out. All right, we can use a SQL injection attack to get that information when we're not supposed to. All right, so this is a select statement right now, where we're going to be, what do you call it? Getting the user's info. Now, when you're first going about to see if something is, as a hacker, going about to see if something is potentially exploitable, the first thing some people might do is do the comment, all right, which you'll see has now completely altered and changed the output, right? It's completely changed and altered the output, which means there's no sanitation happening. Again, to show that off, do Bob, enter, and you're going to see that we get info, and maybe you thought the space was messing it up. We could do tac tac, and then you can see it was altered, all right? Because there's never going to potentially be a name. Well, I guess you could have a first name with tac, but this is like the first telltale sign, right? So the next thing would be then there's a lot of steps that go into it. Hacking is not a very fast process. It's very, very slow, all right? Because again, you have to kind of half be guessing what these tables are, unless you know what the tables are, which I guess we could do a query for that. So if we do, because you don't really know what tables they have in their database, you're kind of just guessing. But your guesses will usually be valid because I have a users table. Most likely, you will have a users table. Most likely, Amazon or Microsoft or Google or whatever big server, YouTube, is going to have a table called users. All right, so your guesses aren't wrong. They're most likely they will have tables like that. But sometimes if you're not getting the result that you want, then you might want to do some digging around. So we know in SQL we have a command called show tables, which we can run, which will show us all the table or give us all the table results. So we can try doing a what do you call it? A query like this, because remember we gotta finish up this one so it's valid. So we do Bob and then a quote and then a semicolon to finish up that statement, and then we can do another statement, a semicolon, and then comment out the rest of the line, and we can see what happens here. All right, and it looks like it doesn't like our command. This is another telltale sign. If you're messing around and you're getting errors or other things like this, that shows that it's not sanitized properly, because you shouldn't be getting errors like this, all right, unless your SQL statements are properly going through. If your SQL statements are properly going through, then bad things are happening. Is it show tables on? What is the, let's pull this up. Let's go to SQL here. And we got a database, so you can show tables. I thought it was show tables. Is it just show table, singular? Let's see, Postgres show tables. Where is the command? Is it DT? Is it literally what? What are these commands? My God. I don't even think that's valid. Like SQL. DT. Yeah, that's what I thought. So their example here on the site is utilizing the pre-built-in table to your database, which is going to be the schema tables, which I guess that would work. Yeah, I guess we could just copy this one, because you should by default in your database here have a schema table. So schema, and let's see if this one works. Let's run this. There we go. So this schema thing will show off the schema of everything. So this is going to PG catalog, which I don't even see here. I think it might be a little hidden by default, but there's a bunch of pre-built-in stuff. But in here we can see we have public users, public tweets. These are the two tables we made. So if we're able to execute this successfully, me as a hacker have now found the whole layout of your there we go. I've now discovered the entire layout of your database. I know all the tables you have. These ones are obviously going to be all the default ones because they're the default ones for everyone's Postgres. So everyone has this, all right, in their Postgres. Additionally, I can look through and find the ones that aren't, which is going to be the ones labeled public. So I know you have a tweets one, and I know that you have a users one right here, public users. So now I know what tables I can go after and try to exploit and get. All right, I think this is enough examples of the SQL injection attack. All right, those are kind of the steps you'll go about it. But anytime, again, to reiterate for the millionth time, and I'm going to do it a million times more, you must protect your data. And how do you do that? Never trust the user. They are demons. Think of them as devils. All right. You need some holy water to ward them off. All right. So you need to sanitize everything. Sanitize. Well, not again. You don't have to sanitize, I guess, everything. Just whatever you're getting from the user. Whatever you get from a user, you need to make sure you sanitize. It is a must. All right. Or else bad things will happen like this. And trust me, this is common. Most of the devs out there that are working at a lot of the major companies, you know, they're terrible. They're very, very, very bad devs. Extremely bad. And they do terrible things like this all the time. All right. And exploits only become more and more common. All right. There's a reason. Because they keep doing these. And it's very, very easy. There's actually ways you can go about on Google where if you use the more advanced Google searching techniques, Google actually has indexed a lot of the sites that are vulnerable. And if you do your Googling correctly, you can get a list of sites that are currently live and vulnerable, and you can exploit them. All right, you can exploit them. So we'll go over, we talked about sanitization. We'll go over some pre-built sanitization stuff that's built into the database adapters when we come back from break. So we'll be back in 3 to 5 minutes. If you have any questions, go ahead and ask them. And then we'll continue on our way. All right, so I'll see you guys in 3 to 5 minutes. Alrighty. We are back, you guys, to finish up our day today with our little intro to SQL and integrating with Python. But before we get back into the code, let's go ahead and just do our little intro here. If you're joining us right now and you don't know, we are Rootkit, a nonprofit organization here in the US of A. Don't go to college. Don't go to any other boot camp. Just come to us. All right, we're gonna teach you everything you need to know to get our comp sci cert and then get a job. It's really just that simple. It really is. On top of all this free stuff we're doing, if you go over to our blog, which it's not live right now, we'll have our week 11 giveaway going on, which you can enter to win some free merch. All right, you just have to show that you're subscribed to our YouTube channel, following us on Twitch, basic stuff like that. Additionally, in the description of the video and somewhere on the Twitch page, there's a link to this page, and this is to donate. Again, we're a charity, so all donations are 100% tax deductible. Additionally, all donations are being matched 1-for-1 for the first 10,000 donations. Depending on how much you donate, you will unlock certain rewards like our stickers, our collab t-shirt, and this epic sweater that I got in right now. The exclusive 100-day of Rootkit has the Rootkit logo on the back. And we have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one no one wants to see, shave my beard. All right, no one wants to see that, so we don't gotta do that. All right, alrighty. Let us continue on. I didn't see any questions come in from the break, so we shall chug along here. So as a review, it's really easy to connect to potentially any database. All right, it doesn't have to be Postgres. All right, it's usually just a couple of lines of code. You'll usually always generate a cursor, and that's what you use to mess with the database. for SQL connections, usually things will be in a staging mode first when you first do them on your new inserts. All right, and you must commit them, just like Git. All right, just like Git, you must commit them. All right. Additionally, when you want to get data, like an execute and select information, it's also a two-step process where you must then fetch those records. All right. And there's usually some pre-built options, usually 2, if not 3, which is going to be fetch 1, fetch many, and fetch all. All right. And that will return to you the data that you want to then utilize. All right. Alrighty, so we just finished up talking about SQL injection attacks. Again, just anytime you get input from the user, just do some sanitation. All right, do some basic sanitation, and you'll be gold. All right, you'll be gold. It's really that simple. Just do that, and you'll be pretty much protected from most hackers. All right. Now, there are pre-built stuff in here for doing sanitation for databases. It's a very common exploit, or it used to be really, really common. Now it's just kind of common exploit. It's so common, in fact, that they have pre-built stuff in most of these libraries for protecting against it. But guess what? Most people still don't use them. It doesn't make it. Here's protection. You should use it. Nah, man, I'm gonna go in raw. All right, that's what they say every single time. It doesn't make any sense. Use protection. All right, use protection. It's pre-built in. It's pre-built in. All right, so when you use the execute command, will it bring it up right here? There we go. Now, this doesn't help you with all your sanitation, but this helps you with the most important of things. The SQL injection. This will stop any SQL injections. All right. Well, as long as the library that you're using is programmed well, it will stop all SQL injection attacks. When we hover over execute here, you'll see execute actually can take 2 items, a query and then vars. All right. Query and then vars. Vars are the variables you want to add to your query statement. So right now we've been using .format. No bueno. Don't use .format when you're using execute, all right, on SQL stuff. And again, this is going to be pretty much similar for all of the SQL databases. So whether you're using Postgres or Maria or MySQL or Oracle, whatever you end up using, this will be pretty much the same for all of them. They will all have some type of .execute, and usually the .execute will have a second area for taking in variables. Right, for taking in variables. So if we go into the documentation, you can go searching around and looking on how to avoid, or I guess right here is the basic usage. So this is how the basic usage for using this library. You can also look up passing parameters to SQL statements or something around that, adding values to a SQL statement, some type of Google around there, and then make sure you put the library you're using at the beginning of your search. You'll usually get a search result. All right, you'll usually get a search result for it. Now, you'll see here, I guess we'll look at this one. It's very simple to protect against these things. All we're going to do is very similar to C, because again, this was written in C under the hood. All right. We're going to use %s for strings. %s for strings. This means we want to insert a string value here. You can see here below, there's some other ways of going about it. I think actually everything is %s now. Before it wasn't, but now I think everything is a %s. Don't quote me on that, but I'm pretty sure it's all %s now. You can additionally specify, it looks like right here, like what type of data it's going to be. So date, string, integer. All right. But I'm pretty sure you can just use %s for everything. All right. This is for your query statement. That's the first parameter. The second parameter is your variables that you want to insert in. That's going to be some type of an array or a tuple. It's up to you. Array, tuple, they both work the same with all of the values you want packed in there in the same order you want them to go into your SQL statement. All right. So in here, we would modify this to be %s. All right, so it would just look like this. It would just look like this. And then we do comma, and then we say, we don't have to say vars because it's in the order, but we do a tuple or an array, and then we put in our user input. User input, all right? We're only putting one item in here because we only have one item going in here. Now notice, this has the SQL injection statement in it. That does work. It is a valid SQL injection statement that will work against our database. But now that we're using execute properly, and it was told to us by the devs, this will protect against SQL injection. If we run this, we'll see that the SQL injection does no longer works. It no longer works. We are now protected against SQL injection attacks. All right. Again, you should still do more sanitization than this, because this will protect you against this exploit, but you should still sanitize the input, because maybe you only want usernames or first names with valid characters. All right. This still doesn't stop people from entering like weird characters for their username, like, I don't know, /n or /0, like a new line or a null byte. They could still enter that in as their username, or search that, and you'll see it still happens. It still happens. So this will stop injection attacks. You still need to do sanitization, you know, to guarantee you're getting an email when you're supposed to get an email, when you're getting a number or like a age between a certain range, etc., etc. All right. But this does pretty much most of it for you. All right. It's really that easy to protect against these things. Right. It's really that easy. Right. People try to make it as easy as possible. Any questions with that? Any questions with that? If there are no questions on that, then let me see here. What else do I need to cover? This is pretty much it for the Python library. All right. I don't think we're going to get into anything else, or you don't really need to know much else about the Python library besides maybe some try and accepts, or try and catch. Try and accept for Python. Try and accepts for protecting against your program unexpectedly crashing, right? Because again, you don't want your program just to crash. You want to handle things gracefully. So you have no other option but to wrap these around try and accept statements, because they will always try to crash your program, right? So you got to handle these maybe a little bit more gracefully. But pretty much, I think we're good to go tomorrow to show how we can upgrade our word guessing game or the dungeon crawler game. I think we'll start with the word guessing game. We can upgrade it using a database, right? Using a database. So we know how to connect. We know how to do SQL statements, and we know how to get results. That's all we need to do. That's all we need to do. So our word guessing game, again, we were getting a list of words, and then the user needs to try to guess those words. We gave points. Did we give points on this one? Yeah, we gave a score and was tracking it. And then at the very end, they enter their name to be added to a high score. And all of this was being saved to files. Files. Now we can use a database instead. We can use a database to hold all of the words in our word list. All right. So we can grab a random word in a word list, and then we can and then we can choose a random word from the database, and then use that in here. Then when the user plays the game, they'll get their scores and everything. And instead of saving this to a file, we can now log this on our database. And remember, databases, we're using them locally, but you can have this as a remote server that users are sending their information to. And now instead of this being like a local game where it's just their local high scores, you're saving it all to a database, all right, on a server. And now you can show global high scores, especially when you start then utilizing things like Flask, all right, where you can then make an API that could be used on a website for displaying the results or the high scores, all right? So it's all just a lot of build up. You know, we've been learning a lot of the building blocks to potentially unlock more and more powerful things. Now, not all of you guys are going to be doing all this crazy like development here. We're going over pretty much everything for back end up to a little bit of front end development. So this would be all categorized as full stack. Full stack again means that you can make all of the stuff that runs on a server all the way up to some of the stuff that runs on a client's computer, right? So the whole shebang, all right? So you guys are learning a little bit about everything, so that way, depending on where you go, you'll know potentially the applicable information. All of this is applicable to a certain extent for you. If you're going to go into game development, you're going to be most likely interfacing with the database. So this would be important. Maybe you need to make some APIs or connect to an API for your game in order to get more data. That might be important. Maybe you're going to be doing more website development stuff or full stack. Then all of this is important. Maybe you're not going to do any of that and you're only going to do back-end stuff. Well, you need to know how to connect to a database for most of your back-end stuff. And if not, you're going to need to know how to definitely Google search things because you're going to learn a lot of new packages for the back-end stuff and APIs. You'll be making a lot of APIs, right? Any other questions right now? I think that's about all that we're going to cover, and then tomorrow we'll get into modifying our game. Any other questions in regards to this? I am in VC. Yeah, the only people in VC that can talk verbally would be Discord Premium and Patreon members. And the Twitter does exist. Maybe the link is the link broken on the README? I thought I fixed it. No, it works. I don't know what link is broken right now, but the one in the Discord is working. I'm guessing on Twitch there's one on. Is there a link on Twitch somewhere that's broken? I don't even know how to get to it. I'll look at that later on. All right. Any other questions y'all got? The link for the Twitter in the README is working. I don't know what other link there would be. All right, sweet. So tomorrow, word guessing game. Depending on how that goes, no, we'll spend all day tomorrow on the word guessing game, and then we might follow that up with the dungeon crawler and showing how to integrate. No, I think word guessing, and then we'll get back to APIs, and we'll show how to connect or make an API with the same database that people will be playing the games with, so you can kind of see that whole technology stack, and how we can potentially allow people to see their high scores. All right, that's all I got for you guys today. So if you guys do have any other questions after the stream, make sure you put them in the 100 Days of Rootkit chat, and I'll see you guys tomorrow on the next one.